All right, the video started. Hello, everybody. My name is Brennan Rogers, and for this assignment, we were asked to solve the total volume in barrels of a sphere or this tank that they give us the measurements on in the textbook. So basically, this is what it looks like. They give us all of the numbers in the textbook. We see right here that it is 28 feet. The cylinder itself is 28 feet long, okay? So with the cylinder itself being 28 feet long, they give us that it is 14 feet tall. From the bottom, it is laying horizontally. So they give us that this measurement here. And we notice that at the end, there's two hemispheres. So those two hemispheres might cause a little problem or a little extra work for us to figure out that volume, that total volume. But no need to fear, the mathematician is here. We got this measurement here, which we end up actually not using. But to figure out the volume of a sphere, it is 4 divided by 3 times pi times radius cubed. So we have two half spheres. So we can put the 4 divided by 3 times pi times radius cubed multiplied by half, because it's half of a sphere. So once we get our radius of our cylinder, here, which is 14 feet, so what is our radius? Half of the total height. So we can say right now that our radius of the cylinder is going to be 7 foot, along with this hemisphere and this hemisphere as well. And if you look closely, I numbered this cylinder because we're going to have to find the volume for all three and add them together. So I numbered this one 1, this one 2, and this one 3. Okay, so now that we just found out that the radius of our cylinder number 1 and both of our hemispheres are all the same, they're all going to be 7 foot. They're all going to be 7 foot on the radius. So after we find our radius, then that gives us the go-ahead to start looking for our volume calculations. So once we do all of the calculations and all of the correct plugging in with our numbers and everything, it's going to come out in feet squared. So for the cylinder on number 1, we plug in everything we have here. If you look closely, and you can see that for cylinder number 1, this cylinder here, where it gets cut off by this hemisphere and this hemisphere, so this cylinder right here, we know that it has a height of 28 feet and a radius of 7. So we use this formula, pi times radius squared times height, is our formula for finding the volume of a cylinder. So we take pi times radius squared, 7 squared, times height, times 28, and that gives us 4,310.2651 feet cubed. So now that we have that, we can go on to our hemispheres, which are actually just going to be the same thing, but we're going to calculate everything out and figure out the right answer anyway. Okay, so now we have our formula to calculate the volume. I'm sorry, trying to get this paper right here. The volume of a hemisphere. If you notice, this is the formula to calculate the volume of a sphere, but we have it multiplied by a half because it is half of a sphere, a hemisphere. So we get our formula here, 4 divided by 3 times pi times radius cubed inside of our parentheses, multiplied by a half. So once we plug in our numbers, the only number we really had to find was our radius, and that would be 7. So then we move on down the line Trying to find it here, y'all. We move on down the line and we solve for our parentheses, which gives us 1,436.75504. I used a lot of numbers behind the decimal until we get our final answer, and that just kind of helps with the accuracy of all the calculations that we do. But after getting that number, which really and truly, this number will actually be what the whole sphere of this is as a whole. Because if you just take those two hemispheres and push them together that are the same size, they really are a sphere. But like I said, for calculation reasons and just to show the correct steps of this entire problem, we're just going to make all the correct calculations and solve what we have to solve to find the correct answer. So we come out after we calculate our sphere to 718.3775 feet cubed. And that's going to be the same thing for 2 and 3. Like I said, I have them numbered. So this is going to be 2 and this one is 3. And those are our volume calculations. So moving on to the next paper, we have our next step, which is calculating the total volume for our entire sphere as a whole. And you can just about guess what we'd have to do here. We have the volume calculations for all 3 of our separated problems that we have to solve for. So we have to add them all together. So we add number 1, our volume for this one, which was 4,310.2651 feet cubed, plus 718.3775 for 2, and 718.3775 for number 3 here. So once we add all of those volumes together, we get 5,747.0201 feet cubed. And here is the math, if you would like to see it. Like I said, trying to get this paper right, it's inverted. There we go. So we get 5,747.0201 feet cubed. And then finally, our last step is to convert our new volume that we have for the entire tank itself, and we take that, but wait, it's not in barrels. So we know that from our textbook that 1 cubic foot is equal to 0.178108 of a barrel. This is the number right here, our magic number that's going to help us finish this problem right here. Right here. So I decided to go with a proportional conversion factor. So we know that if like I just said, our conversion factor for 1 cubic foot to a barrel is 0.178108. So if we put 0.178108 barrels over 1 cubic foot equal to X amount of barrels over our total volume that we calculated, we can go from there and multiply diagonally, then divide down, and that will give us our total volume, 5,747.0201 times our conversion to barrels, 0.178108, divided by 1, which will give us the same answer, is equal to 1,023.59 barrels. Or you can move up your decimal places, call it 1,023.6. You can say approximately 1,024 if that's closer to your liking. That about wraps up our question. So whenever asked, how many barrels does our tank hold? 1,023.59 barrels is how much our barrel holds. Now, I have something controversial that I came upon after I did all my calculations for this particular problem. And I came to find that the answer in the book says 1,034.47 barrels of oil. So this kind of raised some flags for me, and I start thinking, like, where did I go wrong? Where did I go wrong? I look over all of my measurements, all of the numbers on my tank, and all of my formulas that I used, and I took a step back and said, well, maybe it's just a problem that they had in the textbook, and I think that's the conclusion that I came to the most peace with, and that's the one we're going to go with. And the right answer is 1,023.59 barrels in our tank. Thank you.